All right, everyone. I'm going to go ahead and get things started. I know we only have 6 folks today, but we'll go ahead and get things started. Demetrius wanted to go over the updates and changes related to EVP and Gateway. So we'll start off with that, and then we can move into some other discussions beyond that. So, Demetrius, if you want to go ahead.
Yes, so thank you, Mark. As you remember, we had like a presentation regarding the re-architecture of OPI VPN bridge with the flexible components that we introduced there. And in order to implement the whole thing, we need changes to several projects. The first one is, of course, OPI VPN Bridge, where the whole re-architecture takes place. But also, we need some enhancements on the current merged EVPN Gateway API that we have under OPI API repo. So what I will show today, it is already tested with the current code base of OPI VPN Bridge in our fork for the re-architecture. And let me share just to explain a bit and give some context to people so they can review it. Can you see the pull request?
Yeah, the pull request is up.
Okay. So if we go to the one of the proto files here, you will see that um, in its component, in its object that you have there, like logical bridge, we have added an extra field on the status, which is like a list of components. And in this list, each of the components that actually implement the configuration that comes through the request, like the Linux general module, which actually takes care of the Linux configuration, or the FRR module that actually takes care the FRR configuration, will report the status and will append that status to that component list. So this is a new object that we introduce, and you can see here in the component.proto. Uh, so each of the item of that component list that is reported in the status will have like a name, which is the component's name. So it can be FRR, Linux General Module, or Linux Vendor Module, or whatever. It depends on the component that actually fills that string here, and also the component status, which the status is like an enum of pending success and error, and that corresponds to the actual status of the configuration. So if the FRR component actually managed to successfully configure the FRR daemon, then it's a success, it will report success. If not, then it will report error, and if hasn't done anything yet, the default status will be pending. And of course, we have also a details string there, where each of the component can actually, in a JSON format, can report extra information that maybe are useful for the user. For instance, an example can be when you configure an FRR, what is the route distinguisher that has been picked, or what are the imported and exported route targets. Stuff like this can be reported in the details string here in a JSON format. And yeah, so this is this, and yeah, so each of the component, as I said, it will be an item on this repeated component list, and will report it in the status of its object, like bridge port or logical bridge, and of course SVI and VRF. And also we have added an extra field on the status, on the overall status section of an object, like the overall status section of a logical bridge or a bridge port. We have added an extra field that is called to be deleted, and this is about um, the status when the user actually issues a delete request, so the object does not immediately get deleted in the database, but it falls in a to be deleted status until all the components delete all the configuration. And when this happens, then the object finally gets deleted from the database. So initially, when the user creates a delete request, we will transition the status to be deleted, and when everything gets deleted from the configuration side in FRR or Linux, then we finally delete the object. Until then, the status of the object will be to be deleted. So those are the main changes for the API. And as I said, this is already tested with the new architecture and is working. And we will need that enhancement for the VPN Gateway API in order to adjust to the new architecture. So please be free and review this PR, and I will answer questions also on the PR, but also now if you have any.
Yeah, I might have one or two. So I'm taking it that the component is basically the linking chain for the traffic flow. So if it's coming in and going to go up through FRR or whatever, this would be the flow of the traffic that's going through.
No. It's not about this. So
Okay.
in the new architecture
Mm-hmm.
that I have presented in the TSC, if you remember, um, the OPI VPN bridge, in order to apply any configurations to the subsystems that you have below, it has like a number of modules there,
Right.
and
Right.
this is what we call components here. So one module can be the FRR module, which is responsible for configuring the FRR daemon. So
Mm-hmm.
this FRR module is a component here in our API, or it can be a Linux general module, which is responsible to configure the Linux subsystem that you have in your ARM cores, in your IPU, DPU. So this Linux general module is a component here. So when that module actually applies some configuration, right? Um, then then that configuration could be successful or not, right? So this module will report the success or the error of this configuration that has been applied to the component structure here in the API, so the user knows which components, which modules are involved in order to apply the configuration, and also what is the status when those components try to apply the configuration.
Okay. So it's basically making sure that you have all the pieces in place and they're configured the way that you want.
Yeah, it's actually for reporting the
Yeah.
status to the user. So that's why this component is on the object, on the actual object, is reported in the status section of
Right.
its object. You can see
Right.
here.
Yeah. So you're just going to have a repeated list of the components to
Yes,
indicate their status and that they're up or down or ready to operate essentially.
exactly.
Okay. And they're going to be configured independent of what we're doing here. Okay. Okay, I understand it. That helped.
Yeah, I mean, I had like just give me a second. I think I had an example somewhere. In the PowerPoint that I have presented to the TSC, I had an example just to show you how it looks like, more or less.
Yeah.
Give me a sec. Um, can you see my PowerPoint?
Yep, I can
Yeah.
see that.
Okay, so here you see when we create a VRF here,
Mm-hmm.
all right? Then when you create a VRF, you create an intent, right? The configuration has not been yet applied by the modules, by
Mm-hmm.
the components that you have. So you can see here you have like a list of components on the VRF status. where you see all the components that are involved, like Linux general module, Linux vendor module, FRR, and IPU. Those are the modules that are responsible for applying the configurations to the different subsystems that you have. And the initial status is pending, right? And
Right.
when you, like, if you wait like a second or something, and then you do a get VRF of the VRF that you have created, then you will see the status of its component. It is a success now, right? And on the details, you have like a JSON formatted string where its component reports useful stuff back to the user around the configuration that has been applied. For instance, which routing table has been picked for that VRF that has been created in the Linux subsystem, or which route distinguishers, router MAC, exported route targets, imported route targets has been generated, all those stuff.
Okay.
Yeah.
Okay. Yeah. No, I understand. Makes sense now.
Yeah.
Okay. Nope, I don't have any other questions right now.
All right.
Anyone else have questions? Okay, guess not.
Okay, so please review the PR. I'm happy to answer any comments. Yeah, it's up there. Please, if you find any time, I will be happy.
All right, great. Thank you, Demetrius.
Thank you, Mark.
Okay. The other thing I wanted to discuss briefly today, we've been talking about working through some of these initial APIs. So when we take a look at things from a high level, one of the things that probably needs to be decided or at least thought about is when we look at an MXPU, IPU, DPU, whatever we want to call it, do we want to consider it to be a platform from a high level perspective, or is it a device, or how do we think we want to treat it? I've looked at it from a couple of ways. I don't believe that it should be a platform. Potentially it's a device, but when you look at how things are delineated in some of the object definitions, I mean, this could basically become a line card, which you could treat a line card as a device. So I'm just wondering, does anybody have any thoughts around that particular area in terms of how we should treat it at a high level? To me, a device could have interfaces, and then of course we want to be able to set up the interfaces as, you know, the types of services that are there. You know, is it an Ethernet interface, or is it, you know, in the future some other kind of interface, etc. So any thoughts there? Okay, we got a quiet group today.
Mark, can you
Oh,
please
go ahead.
repeat the question again, because I missed that?
Oh no, I've been trying to figure out, or at least think about, how from an object level we want to look at an IPU, a DPU. Do we want to look at it as a platform? You know, because you could do a platform definition. To me, I think a platform is an overkill for this, because a platform implies more or less, you know, you got the entire bus structure, you may have memory components, et cetera, et cetera, et cetera. Another way to look at it as a device, and a device could be the equivalent of a line card, which is exactly what a DPU and IPU is today, at least in terms of its definition. Or do we even want to worry about declaring it a device or anything else, and just look at it strictly as, you know, it's a platform with a bunch of, or it's a thing with a bunch of interfaces. I don't even want to call it a platform. So I'm just trying to get a feel from the group as to their thoughts around that.
I mean, in my head, it should be like, I mean, all the cards are different, right? So
right.
They have their specifics, and it's difficult to have like a universal thing to work on all the cards. So I think we should treat them as a card mostly,
Okay.
not like
Okay.
like a platform. But I'm not like an expert on that, so maybe others have like better approaches.
Yeah. The reason I'm asking, I tried to start to look at this from a high level view, and I'll pull it up so people can see, and it may be difficult. I'll have to scroll around some, but let me share what I started putting together. This is just a Visio diagram, but at a high level, if you look at something from a platform, right, you've got components, you've got subcomponents, you've got definitions that they call a chassis, definitions of what's a line card, and then you can have ports and transceiver configurations, and you can just keep going on and on. These are the things that seem to, if you looked at it as a DPU, IPU, these are the things that you would say, well, these probably apply, but I don't see that the things up here at the top where you're talking about component and subcomponent or a chassis really applies to an IPU DPU, right? Another choice would be to look at it from a device, which is a completely different model characteristic. And then if you look at it strictly from an interface, right? An interface really is looking at the physical port interface where you're going to have interface types, MTUs, loopback descriptions, etc. You can then define from an interface, you can have sub-interfaces of which one type is a VLAN. There are other sub-interface types that you can put in there. When you expand to a VLAN, you can be either a switched or a routed VLAN, so you have those definitions that have to be laid out. And then, of course, you have Ethernet in terms of looking at an IPU DPU. So I'm just trying to look at this as a high-level model view and start to try to map this out to see how we can make this type of a model fit into what we're trying to accomplish by defining an API and looking at it from, I have ports or interfaces that I have to put different parameters and be able to control them from. And then from that perspective, start building the way up from, physical ports where you may configure something versus virtual ports where you're going to actually create and assign them as logical entities to something physical. And then beyond that, building up to the layer 2 type functions, layer 3 type functions, et cetera, et cetera.
Is this bit like kind of a DMTF resource model type view of things? Yes.
It kind of approaches that, yeah.
Yeah. So in my mind, it probably is necessary to go for some kind of subset of platform in that case.
Okay.
I vaguely remember it's always quite complex when you start modeling things that are like platforms in their own right, but plug into a chassis as a submodule. I'm trying to rack my brains for how we've done that in the past, and I can't remember honestly.
Yeah, I've been doing the same thing, Donald. It's one of those things where you start beating your head trying to go, there's got to be a way to do this, and that's why I'm putting it out there for the group, just to kind of say, hey, anybody have any other ideas around this? Okay, well, I'll keep iterating on this, and then hopefully I'll have something that I come up with that I can put forward to the group.
Mark, this is only interfaces and platform, right? It does not cover the accelerators which are there on the DPU, the logical blocks for functionality.
When you look at platform, now platform doesn't really cover the accelerators. There we go. Which, again, that could be another piece that you add into here, right? You could put in another block for, acceleration functions.
Okay.
But it's really, I'm trying to look at the existing models that are out there and seeing what the different pieces are that exist And then from what's existing, you know, we can identify what's missing, add in what's missing, which again, accelerators would be a piece. The question is, you know, do we, again, do we define it as a platform? Do we define it as maybe a line card? Which to me, I think line card is typically, you know, in this context, it's really trying to tell you, is it enabled? Because that's really what all the power configuration and state say to it. And then what are the resources that are on there? You know, and it's really around
Mhm.
memory resources. It doesn't go into any additional details.
Mm-hmm.
And I think, you know, there may be a better way of defining it as a device, because a device can live within a chassis or a line, you know, something like that. And it's a device that could be a line card. It could be something else.
Yeah, the
So
other
anyway.
thing is the accelerators would be, I guess, one leg out of this tree, and then
Mhm.
we can have those accelerators either on hardware, or it could be a logical block in the software that one can configure.
Right.
That possibility also exists.
Right. Yeah, that's why I decided to go back and try to see if there's a way to kind of model this. So I've just been kind of throwing these around in diagram form to try to see how can this all map out.
Okay. Do you want to include those possibilities in this diagram so that people are
Yeah.
aware that we are talking about them also?
Yeah, no, I'll add that. I'll add that in as an accelerator into the diagram.
Yeah, I mean the hard accelerators versus soft accelerators as well.
Yep.
Okay.
It's a good idea. So I'll add that in. Okay. I wanted to put this forward just to get some thoughts, to get some people thinking about it. Once I get something a little more concrete, I'll put it together in some sort of a reasonable format, put it out there for review and comment for everyone. Other than that, that's really all I have for this week. Anyone else have anything they want to bring up or talk about?
So last week, I think it was Boris mentioned during the conversation about prerequisites for some use cases that some of the networks set up for the security or for the storage use cases, were scripted. And I went looking to see if I could find the script, but I couldn't find it. But I thought maybe looking at that script would give us a good view on some of the baseline necessary bring up. So if somebody could point me to the right set of scripts, that would be really, really helpful.
Okay. Yeah, I'll see if I can find them, Donald. I've been through some of those things in the past. So let me go jog my memory on the scripts and where they're at. But a lot of the network setup that's created is done via kind of a script environment. And then once it's set up, they start executing things. So let me find all that data.
Yeah, I found some Ansible playbooks. I wasn't sure if that was part of it, but some pointers would be really helpful. Yeah,
that's the new stuff that I know Boris has been really focused on the Ansible to look at it from a provisioning perspective. But there are some default environments that he has put together in some of the storage things where, you know, let me find the data and I'll point you to it.
Awesome, thank you.
Sure. Any other topics to cover this week? Okay. I am out next week. I'm on business travel and I'll be on airplanes during the meeting on Thursday. So I'll put out a query into the team group to see if anybody wants to host the meeting. Otherwise, I will cancel it for next week and we'll pick up in 2 weeks. But thought I'd pass that on. All right, everyone. It's been a 30-minute meeting today, but I'll give you a little over, or maybe just a little under 30 minutes back. And we'll meet again in 2 weeks, unless somebody wants to take the mantle for next week. Other than that, have a good remainder of the week, and we'll chat again next week, or the week after, sorry.
Thanks, Mark.
All right.
Thank you, Mark.
Everyone.
Goodbye.
Thanks, Mark.
Bye.